Okay, Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to greet to all lecturer of research methodology, Mr. Nana. Today, I want to present about my research proposals with the title Comparative Performance of Naive Bayes and Bird Models in Sentiment Analysis with web prototype of Amazon product reviews. So, what we will discuss today is research background, problem statement, research gap, research methodology, research workflow, research validations, and the last one will be web development method. So, for the background of the research was talking about the increasing the use of e-commerce platforms such like Amazon. Maybe in Indonesia we use it a lot like Shopee or Tokopedia. The volume of products reviews from the user or that was generated by user has also grown exponentially, grown so much really big. These reviews serve as a valuable things and valuable data for the business owner to understand how was consumer perceptions or maybe how for they to improve their product or their businesses or their services so that their business can be absolutely better. So the sentiment analysis, also known as opinion mining, is an NLP, natural language processing technique, used to classifying opinions or emotions expressed in text into categories such as positive, negative, or neutral. In this study, we compared the major approaches in sentiment analysis using probabilistic naive Bayes and the deep learning BERT models. Naive Bayes is also known for its speed and the ease of implementation, whereas BERT offer high accuracy and its ability to understand language context. We aim to evaluate how both model performs on a real-world datasets, especially Amazon product reviews, which are often filled with challenges such as sarcasm, class imbalance, and ambiguity. Furthermore, the results of the analysis with the implemented into a web-based prototype to demonstrate how sentiment analysis can be applied practically. So our problem statement or research gap was several previous studies have compared the performance of naive-Bayes and BERT in sentiment classification task. However, many of the studies were used synthetic or simplified benchmark datasets that's not reflecting the real world data. There remains limited comparative evaluation of these models on domain specific datasets like Amazon product reviews, which exhibit unique characteristics such as sarcasm, ambiguity, imbalance, sentiment distribution. Moreover, few studies have translated the finding into practical applications such as web prototype or systems usable by end users or companies. These research aim to address these gaps by providing comprehensive evaluations and practical implementations of this model in real-world environment. So for our research methodology, we use quantitative approach as it focuses on objective measurement of the model's performance. With this approach, we're able to measure and compare metrics such as accuracy, precision, F1 score, and then evaluate each model capability in handling real world cases such as ambiguous reviews and imbalanced sentiments. And the third will be provide reproducible and objectively comparable results. Unlike qualitative methods, which tend to be more subjective, the quantitative approach provides strong empirical basis for drawing valid scientific conclusions that are useful for both businesses and academic purposes. So, what's the difference of our method and the previous studies? Most prior studies have only used the one type of model. Example, they only use net-based for sentiment analysis, or they only use BERT, and typically conducted experimental on ideal or clean datasets. So in contrast, what we do was conduct a direct comparison between NAF-based and BERT, use real-world Amazon reviews datasets that include various linguistic challenges, implement the results in a web-based prototype as a proof of practical deployment. So we choose this approach so that the findings benefit not just only in theoretical understanding, but also offering immediate solution or applicability in a real business case or scenario. So our workflow was conducted by a few steps. So the structured workflow and systematic was the first. We will collect the data from the Amazon product review and gather from Kaggle and academic datasets, and then text pre-processing. We will include slower casing, tokenization, stop word remove, stemming, lemmatizations, and negations handling. Model implementations for the naive base, we will use back of words and CFIDF. And for BERT, we use true fine tuning of the pre-trained BERT base base models. Yes. Performance evaluations using metrics such as accuracy, precision, F1 score, and recall. And for validation, we use cross validations and testing across different subsets of data. For the web prototype development is to visualize and demonstrate the analysis results in a real time. We will using a agile framework. Okay, so for research validation, we use three type of validation: internal, external, and practical validations. So for the internal validations, the method that we using was k-fold cross validations. In here, we use K5. Uh, the step of doing it was we split the datasets into five equal parts, and then each fold was used once as a test, while the remaining folds were used for training. Final performance metrics like F1 score is the average over all five runs, and this help prevent overfitting. Yes, overfitting and ensure that the consistent model evaluations. And the second, external validations, the results were compared with the finding from prior studies, like on the prior studies says that Bird outperforms Snake-based in handling complex language structures from Munikar and also Jayadianti, and also Snake-based remain efficient for small-scale or real-time tasks from the Meshram and Sahu. So this is like to compare that uh, from the prior studies, and what do we find is to compare like is there any difference, and then ensure alignment with existing literature and validate novelty. And the third is practical validations. Mm, for the practical validations, we use soon best performing model, uh, probably birth was integrated into web-based prototype, allow real-time sentiment classification of Amazon product review, and then demonstrate practical usability for business case. And then for the application development methodology, we selected agile method for developing the web prototype due to several key advantages. So the first one will be iterative and flexible, allows for continuous improvement and adjustment throughout the development process. User-centric, enable ongoing feedbacks from potential users, helping refine features and enhance UI UX. And then fast and adaptive, well suited experimental and research-based project like this one that we work on. So we have a little bit comparing with rigid waterfall methodology. So compared to the waterfall method, agile supports more incremental design and testing. This approach allow us to first identify and resolve issues early, adapt and changing requirements, and then third, ensure the final product meets the user need and aligns with the research goals. Okay, maybe that's all from my presentations. Hopefully, this research can be useful for business person, business stakeholders out there. Uh, if we soon finish this research. Okay, and also I would like to say thank you to all lecturer of research methodology, Ms. Lana, for the guidance on making this proposal. I would like to say thank you very much. Thank you for having uh, the attentions. I would like to say Assalamualaikum warahmatullahi wabarakatuh. Thank you so much.